So I want to bring on our very first interview for today, and that is Alex. Alex is the co-founder CEO of Matter Labs. You may know more frequently as zkSync, and we're going to have a chat conversation around how we can scale all of this even better. So welcome, Alex.
Thank you, Kartik. It's an honor to be here, and we're really excited for this interview.
I am equally excited to talk to you officially on stage. We've had a lot of these when nobody was listening, so let's change that a little bit. You've been working on scaling Ethereum for nearly 5 years. I want to start off by just kind of having people know about what you're working on, how we got started, and sort of what was the actual insight that made you sort of go all in on this being the problem that you needed to solve.
So you guys probably know zkSync. It's a layer 2 on Ethereum using zero-knowledge proofs. It's been the first ZK rollup on Ethereum. We actually built the very first working ZK rollup, so it's always been in the ZK space. My motivation for doing this was solving problems that we need to solve to get Ethereum to the mass adoption. So I came into crypto space out of convictions that freedom is the most important thing you can improve in the world, and it was the intersection of the technological, really challenging, interesting technological things, and this the passion for freedom that I had, and it was clear that we need to solve scalability. We need to solve a few other things, but scalability seemed like a really, really hard problem. And it was not until zero-knowledge proofs appeared on my radar that I had an idea, like how can we do it fully preserving the properties that made Ethereum and Bitcoin before that really valuable. And if you think about these properties, it's, yeah.
That was my question.
The story of building Matter Labs actually illustrates what they are. So when I was first talking to investors, and I remember talking to you 5 years ago in San Francisco and to others and trying to sell this thing, ZK was a very little known term, very little known concept. It was actually...
Zcash just came out and we're just figuring it out what to do.
Yeah, but like most people perceived it as just the privacy thing and something weird and far from reality and very complex and expensive. But it was very clear to me that this is a breakthrough technology that will transform the world completely. Like it was clear that we don't have the protocols right now that are capable of doing this, that are production ready, but the pace of the scientific progress in this space was so fast that it was clear, like maybe in 2 years, maybe in 3 years, in 5 years, but we will get the product. We will get there. It's like the curve is convexing. So I was, and then like once we get there, the properties that this technology give you were really feeling like magic, and people were referring to zero-knowledge proofs as this magic moon math, and not without a reason. And so I was trying to convince people, and everyone was like, "Meh, I don't know, like it's risk confirmation." You know, like it's hard. Like if you're not a scientist, it's very hard to understand this concept and see beyond. So the great thing about capitalism and Ethereum blockchains specifically, and the digital world is we have very little regulation. There is a very low barrier of entry, and we have this amazing world of VCs who are willing to take risks. Like you don't have to convince them to 100%. You just have to convince them that there is a slight chance that this can become big. And then they are willing to support you. And this is very different from a political world where you have to go and convince some powerful, mighty party that this is absolutely the right way to go forward. And you have to provide evidence, and like you can't talk in probabilities.
Innovation doesn't happen when it's masses convincing.
But innovation is the most important thing that drives wealth, progress, prosperity, happiness for us as a species. And innovation requires experiments. And so like we need to lower these barriers of entry. We need to keep and this is why we always, like my conviction was that the most important properties of blockchain systems are permissionlessness, like this absolute inclusivity. Anyone can come and start building things, just deploy a contract or download a wallet and start using it without asking anyone for permission. And you can start innovating. You can just build products, and people can instantly access it. And it's all an open system, just like the internet. In fact, for me, the Web3 is just a continuation of the internet. It's this next wave that brings value on the internet. Like blockchain is the value layer of the internet. And so I'm absolutely convinced that all of the value transactions of the world will come to blockchain with the magic power of zero knowledge proofs, because it just gives you something very unique that you don't get from other technologies.
So let's contextualize this a little bit. So what there's an argument for, okay, well, we kind of saw as a mathematician that this is what's possible, and then it's now an efficiency game, or sometimes just some better enhancements around it. But concretely, what does it let you do better that helps you actually set any blockchain up for success in the future?
So I'm not so good in information theory to give you an exact definition of this property, but I intuitively feel it, and maybe I'll try to explain. It's kind of like compression of the integrity of computation. Like you compress certain information that you pass over, and like from there you get two properties essentially. One is scale, or even hyperscale as we call it now in zkSync. So you can extend the computation indefinitely. You can like process all of the world's value transactions in parallel, merge them in parallel in one succinct proof, and this proof can be verified by any like mobile phone, any clock, any Raspberry Pi in the world in like just a few milliseconds, right? This is really powerful. Like, so the scale is one thing. The other thing is the protocols are called zero knowledge proofs, meaning that you don't disclose any additional information about the fact of the computation and the fact that the computation is correct. But in fact, the systems that we can build on top of the zero knowledge proofs, I would call them like partial knowledge systems. So maybe an analogy that will help you understand this is when you get a payment, let's say like you have your banking app or a Venmo or PayPal or whatever, and someone makes a payment to you. And you see on the display of your app that I received this payment, right? And you know how much you received, and you know your new balance, and you can see all the payments on your account. What matters to you is to know that this payment really happened. That it's like there is a world consensus that now you have much more money. You can go and use your credit card and buy some goods, and people will actually take this money from you. But you don't have to know anything about all the other world's accounts in this bank or elsewhere. Right? So you only care about this computational fact, but you need the partial knowledge of the entire system. Because if you had to know all of the world's accounts, that would not be scalable. Right? So this is like, practically speaking, if we now go back to like in practical plane on like speaking about ZK rollups specifically, we solve computation completely. Like we can process infinite number of not infinite, like unlimited number of transactions. But we still have the data availability problem. All of the ZK rollups, how many of you guys are familiar with ZK rollups and like how they work? Okay, most of you are. But so you know that all the rollups, ZK and optimistic combined, are using the same fixed throughput of Ethereum data availability layer. So we can have, like today, we can process up to, I think, like around 1,000 transactions cumulatively across all rollups. If one rollup does more, others have to do less, or the price will go up, and the price will go up. And even with after proto-dunk sharding, and even after dunk sharding, we won't get to an infinite throughput. Like,
I want to cover that as well.
Yeah, so we'll talk about that. But with zero knowledge proofs, you can build systems that use hybrid data availability models, such as Volition. In zkSync, we have an implementation called zkPorter for this, where a single rollup can have accounts that are like ZK rollup accounts that inherit 100% security from Ethereum. So you have theoretically, like if there is no bug in the implementation, you have exactly the same security properties as though you are on a contract on Ethereum. But in addition to that, you can have this zkPorter accounts that are elastic. You can grow them like much higher than the rollup accounts. And you don't have to publish them onto Ethereum, but you still have access to all the other rollup accounts. And you can still, like, each of the system can talk to any other system, and you don't have, like, the systems can trust each other because they have this integrity from zero knowledge proofs. And on top of that, you also get privacy. And privacy in ZK rollups, implemented in the right way, something like zkSync is doing, is going to be extremely cheap. Like it's gonna be like if on Ethereum now you have to pay like dozens of dollars for a single SNARK to verify, on zkSync it will cost you like 0.1 cent, like under 1 cent, extremely cheap. So like all the privacy applications are coming to blockchain with this.
Okay, that was an awesome primer because it actually sets up us for the next 15 to 20 minutes of other questions. So let's kind of dig into some of the things that you said. Of course, the magic here for this this moon math is that you can do all these things and they're guaranteed to be correct, because if they're not, then the rest of the system doesn't kind of proceed. So it's all or nothing kind of actions. And the best thing here is that all these proofs, like to contextualize what a proof is, at the end of the day, you're coming with a string, which is like a hash of all that data. And in most cases, that hash stays constant. That's kind of the recursion that's coming in. I can have 1 million transactions or 2 transactions or 1,000, and the size of that proof for any of those will still be the same thing, which means it's quick to verify, it's quick to store anywhere, and you just have the ability to construct the same proof later if you want to really verify and do the math again. All of that is now, in a way, anywhere from benefit of hindsight to things that we've learned. So my question to you is kind of forwarding and going back and forth within the last 5 years, what were some of the things that you had to anywhere from invent to figure out to improve to get to where you are now? Can we talk about some of the advancements you've made? Can we talk about some of the breakthroughs or the actual benchmarks to things that you've built, and kind of what was the state of the art before and what's happened since?
So we are, I'm incredibly proud to have a really, really strong team at Matter Labs, the core team of zkSync. It's not going to be the only team working on zkSync, but it's the original one. And we made a number of things for the first time on Ethereum. Like, as I said, we built the very first ZK rollup, and we have brought the very first implementation of Recursion to Ethereum. We built the very first, like we came up with the idea of ZK-EVM, that you can actually do it, and we built the first working version of ZK-EVM. It's been a work on the shoulders of giants, of a lot of researchers and other developers and other contributors to the space who are like, I have extremely high respect for. Like our team's contribution is tiny compared to all the body of knowledge that was created before us. But maybe I can focus on the most recent things that I'm most excited about. Like this week, we announced a new proof system called Boojum, which is an implementation of the proof scheme called Redshift, which our team came up with as a byproduct of the work. Like we did.
I remember that from yes.
We didn't actually intend. Like we were always very practical, very applied research. But we saw a Plonk coming out, and like what's a Fry system, and my co-founder was like, "Oh, like this is interesting. Like we can, like if we combine this and that, we can get some new properties." So the combination of Plonk and Fry, we called it Redshift. It was not practical until the Mir protocols and now the Polygon team came up with Plonky2, where they applied the smaller fill to it. And the Plonky2 is actually an implementation of Redshift. And now we came up with another implementation of Redshift where we made a number of things completely differently and made a lot of improvements. And now we made the benchmark with Seller. We made them somewhat incorrectly. So it's now like in the, like almost as fast as Starkey, slightly behind Starkey in the benchmarks. But we used the wrong hash function, so we are slightly above Starkey. So it's like fastest from all the benchmarked systems in the world. We'll update the benchmark soon, and it's like it's more than an order of magnitude faster than Plonky2, orders of magnitude more performant than the existing proof system we use, and this is going to push the boundaries of what's possible computationally on ZK rollups like very far.
What's a better way to understand what this order of magnitude actually looks like? Are we talking about something becomes from a few seconds to a few hundred milliseconds, or is it like we've reduced the requirements? Like how do we actually make sense of
think
this?
about performance of proof systems, we have to remember that the computation is always done in parallel. Zero knowledge proofs are really well parallelizable. So what matters is Like your performance comes down to the matter of cost. Another important
cost of hardware, or what?
Cost of computation, yes. So like which boils down to the cost of hardware that you can rent somewhere or you own. But you probably want to rent it. You want it to be elastic. You want, like, if there is higher demand, you want more instances of your prover. If there is lower demand, you want to roll it down. You probably want to use very efficiently parallelizable hardware for this, which currently the best choice is the GPUs. So we actually have also an implementation of GPU prover for Boojum, which is only requiring 6 GB of RAM. So it's like compared to all the previous to the best of my knowledge to the existing provers out there, it's a massive improvement. Like I know like some of the competitors were running as recently as like a few months ago prover of 500 GB of RAM, which you can only run in the cloud. And so you become heavily dependent on this cloud. This is not what you want. You want to decentralize the proofs. You want to decentralize the sequencer. That's the core of our ethos at zkSync. Then we're working on both. But the key enabler to decentralizing the prover is getting it on a GPU hardware that is like consumer grade, that can be run in the cloud on any GPU instance that is used for machine learning or whatnot, or on GPU mining rigs, or even on home gaming
rigs.
Yeah. So like so this is the really interesting thing. It's already live on Mainnet in shadow proving mode. So we're currently testing it we run the proofs on the old proof system, and in parallel we run the proof for the exact same blocks, because they were designed to be future-proof with the choice of the hash function and the architecture of the storage. So we can easily switch the proof system. We can easily switch the field used in this proof system. And once it's after a month, we will complete the security audits, and we will just switch to only the new proof system.
So the end user doesn't notice any difference because you've just improved the internals, or
the users will notice the difference, like
as in terms of they don't have to do anything new to still.
Oh yeah. So the users don't have to do anything. Like it's completely transparent. Like nothing changes from the user perspective, except for the cost. Like with the new proof system, we'll be able to make the blocks essentially unlimited. They will only be limited by the throughput of the sequencer. We like the new construction, and the construction we use in the virtual machine now, not in the proof system, but in the virtual machine design, enables us to do arbitrary long execution trace. So we don't have a concept of a block limit. In Ethereum, you have a block limit of like 15 million gas. In zkSync, you don't have it. You can like have 100 million, like 150 million gas in a single block, in a single transaction, whatever. Like we can.
Because it's just the proof that matters. Doesn't matter how.
Yeah. And again, the proofs are parallelizable. So like once we close the block, we can just spin off number of instances to prove this block, and we don't have to worry about it. What we have to worry about is the sequencer, because it's EVM compatible. So we are on the sequencer in the EVM paradigm, like sequentially. Every transaction is executed after another. Every block access is, storage access is executed after another. So sequencer throughput matters. We knew this, and this is why we were building. We do not reuse Geth, for example, because we know it has existing limitations that other teams struggle with. We built a sequencer node completely from scratch in Rust, and our current sequencer node enables something like north of 100 TPS of average transactions. Like what we see in the mix of like different DeFi NFT projects. Like if you take an average transaction, it's something around, I think, 200K gas. I'm not sure exactly. I don't want to lie here, but like an average transaction, we can do like over 100, 130 or something like this per second today. And we're still working on improving the sequencer, and at some point we can parallelize it. But like we have a really high buffer. Right now, zkSync is doing around 10 TPS on average for the past months.
That's the current usage, you mean, not the capacity?
That's the actual demand. And the capacity is like 10x, 13x more than that. This usage actually makes zkSync one of the most battle-tested L2s. Like we are actually the most used L2 over the last 30 days average. Like we're just above Arbitrum and like far above everyone else.
Oh, that's an interesting one. Interesting. Yeah. All right.
Yeah, so I highly recommend L2Beat as .info as the
source.
resource for all this metrics for TVL. Like we're a third L2 by TVL and first L2 by usage.
That's an interesting point. So let's talk about this. We're obviously seeing multiple approaches to solve scalability. We just talked about ZK rollups here, and that's what you're working on. There's also optimistic rollups, and we have some other kind of brand new ways to think about things like Starkware in the same kind of field. But we kind of are seeing a lot more people experiment with optimistic rollups, or you kind of see anywhere from Base to recently Celo. I'm going to kind of do a version of this for future speakers too, but how do you kind of perceive what it means to kind of use optimistic rollups here, and what's kind of the framework around when somebody should consider ZK rollups versus optimistic rollups?
I think one advantage optimistic rollups have today is that you don't have to wait for the proof generation, so your latency could be kind of synced with Ethereum, and you can do like every block you can do some checkpoint on Ethereum and kind of like make it harder to revert this checkpoint. It's not impossible, but it's harder, right? We can use this in zero knowledge in ZK rollups as well. It's just not been used so far, but like it's easy to add this property. Apart from that, optimistic rollups are currently cheaper. Well, not optimistic rollups, or like the optimistic execution, if you want, would be.
Can you clarify what optimistic execution is here?
That's a really good question. Like, and maybe like optimistic rollups cannot be detached from the problem of data availability. So like we see a rise of this optimistic chains, so-called optimistic chains, which is essentially reincarnation of Plasma, a protocol we've been dealing with, like, or experimenting with 5 years ago. But it's essentially like the security assumptions come down to basically the same properties as the side chain. So it's probably not really a good term. But like if you look at the optimistic rollups, systems that publish data availability on Ethereum and derive security from Ethereum, because anyone can challenge the invalid states that the sequencers would be publishing. Which, by the way, I don't think we have optimistic rollups that actually have permissionless fraud proofs. But apart from that, the optimistic rollups are fundamentally going to be more expensive than the ZK rollups. Right now, they're cheaper, just because they had a few years had time to implement data compression. This is coming soon to zkSync, and I know that other ZK rollups are also working on this. This will lower the costs by 50, 60, 70%. But just like simple compression, like instead of the address, you put the ID of the address. Like you use dictionaries, you compress the numbers. Like you don't have to publish 32 zeros, you just publish 1 0 because it's like some numbers are more compressible. But once we have that, we will be roughly equivalent. But after that, we add compression uniquely enabled by zero knowledge proofs. For example, reusing of the state. So zkSync,
recursion or different.
Like zkSync and StarkNet are the only two L2s that publish state diffs instead of calldata. We have an architectural choice where we don't publish every single transaction on chain. At the end of the block, we only publish what has changed in this block. So like if you have like 1 million or like 1,000 like NFT transfers, then you will have like 1,000 updates, and optimistic rollups will have 1,000 inputs for all these transactions. But for different transaction types, like let's say Oracle updates, 1,000 updates will end up like they constantly update the same storage slots in the same contract over and over again. They just adjust the price. So at the end of the block, if you do 1,000 Oracle updates, you will only have to pay for one if you're using like our approach. For optimistic rollups, they will have to pay 1,000 times. So for applications like this, same with AMM access, like if you are doing an arbitrage from a single trading account to the same AMM pair, at the end of the block, no matter how many transactions you do, you will only pay for one. And we can nicely amortize this across all users. So if some like, let's say, Uniswap trading pairs are more popular, they will become cheaper the more people use them in the batches. And the batches can be large, like can be like 20 minutes, which is like thousands of transactions, right? So this will enable a completely unique cost lowering for ZK rollups versus optimistic rollups. And on top of that, we have Volition, where the access to retail users will be like flat at under 1 cent. no matter what the gas prices on Ethereum are.
How does that work?
Well, you split the state into like ZK rollup accounts and zkPorter accounts. It's all part of the same state, so you can instantly access, like zkPorter users can go and trade on Uniswap in a seamless way, exactly the same way the ZK rollup users would do. But for them, we don't publish these state diffs for these accounts on Ethereum, which means we publish them to some other data availability.
Right. So it's just cheaper.
Network.
I see.
So it's cheaper. You don't have the same security as Ethereum. It's a trade-off. Like your security pool is going to be lower because now your data availability committee could theoretically freeze the state for everyone. Like the quorum controlling this committee can say like we're not going to publish data. So you need some economic incentives for them not to do this, which is going to be like probably some form of stake. You have to stake something. So like if you freeze the state, your stake will kind of burn or become like not valuable. But nicely, this will not affect ZK rollup users. So all the like LPs with a lot of capital will be using ZK rollup accounts, and all the retail users who are opting into this slightly lower security but still enforced by zero knowledge proofs, like the operators, the sequencer cannot steal funds, cannot invalidate mess with the state. They can only execute what the users promised them. It's just like the state is like not 100% secured by Ethereum. But you have access to the best liquidity in the world because you're working with like the super secure counterpart.
Interesting. Maybe kind of on that similar topic. Let's talk about what developing on top of ZK rollups is like. So you introduced something called the ZK Stack. What is it? Kind of what was your focus around ZK-EVMs, and why did you choose that route, which requires a lot more work, and why did you kind of think that was necessary?
Well, ZK-EVMs was like a necessary choice at the end once we could implement it because we are scaling Ethereum, and there are massive network effects around the Solidity as the language, libraries, existing code bases, existing projects with all the code bases for them, and the tooling. You want to reuse all of that. And if we had to introduce a new language or even use something like Rust, we would have to create an entire ecosystem around that. It's difficult. Like we see it with Starkware, Cairo is doing that. It kind of takes time. Like you need to invest a lot in this, and then like we wanted to reuse these open standards, open like just have a continuation of Ethereum. We just wanted to be a layer extension of Ethereum and not something entirely different. So it was not a choice. Like the moment we could do it, we did it, and
seems like it's working well.
It's working quite well, yes. So what was the second
just,
part?
ZK Stack.
Oh, ZK Stack. ZK Stack is important. So ZK Stack is, what is ZK Stack? ZK Stack is a framework you can use to build your own sovereign rollups or hyperchains more generically. Because like ZK Stack is a modular framework based on the code base of Era, zkSync blockchain. So it's a really battle-tested code base with 500 million TVL and like lots of transactions, lots of usage, high throughput. It's very stable. We invested a lot in security. We spent over $4 million in security audits, contests. We're doing defense in depth, like several other measures in addition to the correctness by construction. But ZK Stack now enables you to like deploy to create your own blockchain, deploy it, and modularize, like customize the modules. So you can say like, I want to use my own sequencer, or I want to take this decentralized sequencer based on hot stuff consensus that Matter Labs is developing, or I want to connect some other, like maybe I want Tendermint because I'm already using it from the Cosmos ecosystem. You can define your own data availability mode. You want to be a ZK rollup, you want to be a Volition with the extension of Validium accounts, or sorry, you want to be a Validium because you're an enterprise chain or maybe a banking chain and you want full control of this data. You don't want to disclose it, but you still want to inherit validity and integrity from Ethereum. So this is why we're not calling it like it's not only for ZK rollups, it's for these different chains. Like various aspects can be customizable, but the most important property of the ZK stack, apart from this interesting thing, is it enables you to deploy your hyperchain not in an isolated way, like completely siloed.
Implying that you need a whole new set of sequencers, validators, or users, or like what does separation mean?
I'll explain now. Like one option for you would be to like just deploy your own rollup on Ethereum and have all the bridging from and to other rollups through Ethereum. The other option is to deploy it as a part of the zkSync hyperchain ecosystem. If you do it on Ethereum, so the analogy I'm thinking of is like rollups are almost like cities. You have different cities, like you live in Paris, like users will always pick one place where they live. All of their assets will live in one place. Maybe not all, but like one wallet lives on one chain. One wallet cannot simultaneously live in multiple chains, right? So like it's like you live in New York, I live in Paris, you live in Berlin, and in your home place where you live, you have some interesting things around. You have some restaurants, some shops, some like you have job to go to earn money. You know, like you can build your businesses there.
Local banks, yeah.
Local, whatever, like infrastructure in this place, and some local infrastructure like to get there. Like some places more efficient, some places less efficient. Some places you get traffic jams every day, you cannot move. Some places you have really good traffic. So like blockchains are like this. Some of them, sometimes they become congested and everything is slow and expensive. Some of them are really fast and reliable. So the problem is you cannot easily go from one city to another. It creates some friction. Even if you're in the same country, like all of the rollups are in Ethereum, which is one land, right, one continent, connected by roads through Ethereum, it's kind of more expensive. Like you don't casually go from like Berlin to, I don't know, Warsaw for dinner or like for maybe like for lunch, right? You don't just go, I'm gonna jump on a train, go 4 hours there, pay a lot of money just to go for like this simple lunch and then go back to Berlin. You don't do this. You maybe do this when you kind of have something special, like you want, like maybe you live in Paris or you live even in Berlin, but you want to go to Disneyland. So you fly over there, you spend an entire day, go on all the auction attractions and so on, and then you go back. So this justifies the trip, right? But you don't do it casually. Rollups are like the cities, and if you are building a popular generic purpose rollup with some like have something special there, maybe people will come and start living there if you give them like a lot of this generic infrastructure. If you're building an application specific rollup, then you need a good reason for this, like Disneyland, right? So what hyperchains enable you to do is, instead of building your own city far from everything else, you kind of build your own district in an existing city. You build a micro district which is well connected. So like you go and like build on outskirts of Paris like a hub for innovation, or like hub for like luxury dining or something like this. And so like the primitive that enables this is called a hyperbridge. This is something that is only enabled with zero knowledge proofs, because of this partial knowledge and succinctness and computational integrity properties. We don't have time to go in depth here, but I'm happy to like maybe after that discuss a lot. We have enough documentation on our webpage on how this exactly works. Just trust me. Like it's the way you can imagine hyperchains and hyperbridging is, you have in the internet your email at some domain, right? And you, like Alex at Gmail or Alex at MetaLabs, Kartik at ETH Global, and I can send email from any address on any domain to any other address on any other domain at like one click. Or you can go from any web page on the internet to any other web page on any other like domain in one click through a hyperlink. So the cost is always one, like O of one, just like the single transaction on one chain, single transaction on another chain. No trust assumptions, no complexity, like really fast, seamless, and transparent. And this is how this bridging is going to work between hyperchains, because they will be sharing the same bridge, the same assets
about the whole system
on Ethereum, and the zero knowledge proofs that enforce integrity of messaging between them. And so like everything is seamless. Like the assets are burnt on one side, minted on the other side, and it's actually real native assets. So this is why you might want ZK stack as opposed to other stacks that only give you this isolated technology.
Interesting. So it looks like we'll have to do another one on just the stack in the future. Maybe switching gears a bit, what have you been wrong about in the last couple of years?
Oh, lots of things in various ways. The building a startup, building some technology and project is always a series of experiments which you have to run. You have to take risks, and you will fail a lot of time. But you just have to be right enough to not die and just continue building. One thing in particular I can think of is we thought that the progress in zero-knowledge proofs will be slower than it actually happened. I thought it will take like 3, 4, 5 years for the protocols to mature. So and because of this, we started building a custom application-specific language, a DSL for SNARKs, because we thought
Zinc, right?
It was called Zinc, yes. We thought the generic purpose programming languages, like Turing-complete ones, like Solidity or Rust, will be too expensive to implement in near future. So we started with Zinc, which was non-Turing complete. You had to define your programs in a fixed size, but then we quickly saw that it's actually doable to build something like ZK-EVM, and we switched to it. But as a byproduct, we got a really smart and powerful compiler team, like world-class compiler team building on LLVM compiler base. So now we can integrate Rust, for example, or other like a C++ code base, although I don't think anyone will be using C++ so they have Rust, to build contracts that will work alongside contracts in Solidity on zkSync.
That's a pretty good side effect.
Yes.
I want to close off with a question that I think is a bit more philosophical, but maybe also we can quantify it. But how do we actually know we've successfully scaled Ethereum? Like, do you have any predictions or frameworks to think about this for what the next couple of years would look like?
This is an amazing question. We actually we had this criteria of like what success looks like for all the time of existence of zkSync. But we just recently, like 2 or 3 weeks ago, we decided to articulate them precisely in a very positive, like very unambiguous way. And we published something called the ZK Credo, which is a manifesto of values and mission and philosophy of zkSync. It's open on GitHub for community to comment, so please take a look and please engage in conversation and submit PRs. And
ZK Credo?
ZK Credo, yes.
Perfect.
Just Google ZK Credo, you'll find it. Where we define properties that you have to achieve. Like I think there are 8 properties, including trustness, permissionlessness, and so on. And 2 of them are called accessibility and hyperscalability. What is accessibility? It means like everyone in the world has an option, has an ability to go and transact on a blockchain in an affordable manner. In affordable, accessible. Like accessible means like the UX is not prohibitively complex. If you have to deal with seed phrases, people are not going to do it, not going to make it.
Or even start interacting.
If you have to pay like more than like your daily earning, because a lot of people live on like really small amount of dollars per day, and you have to pay like this amount or like 1/10 of this amount for a transaction, not gonna make it. It's not accessible. So we need to get the transactions like under 1 cent or even lower consistently at arbitrary scale. So like hyperscale means we wanted to use the word superscale, that it sounded weirdly like just like you have conductors in physics and you have superconductors. The conductors are materials that have low friction. Superconductors are materials that have exactly 0 friction. So you can like heighten the energy to like current can go forever in those circuits. This is the property of the internet. Like you can grow internet indefinitely. You can just add more servers, more routers, more connections, more users, and it can absorb like 1, 5, 10 billion users, arbitrary number of transactions. Like you don't have any inherent limits to it. This is what we call hyperscalability, and this is going to be completely solved within 2 years. Like this is a bold
prediction. We'll be back in 2 years and we'll kind of contrast. Well, Alex, thank you so much for taking the time, and really
My
appreciating
pleasure. Thank you guys
about everything else.